Hi, hope you enjoyed our video previously on damage insulation, or dam conditions, okay, as well as overloading on cables. Okay, you will notice all of these actually will lead to either electrocution or a fire. Okay, will never lead to any explosion. Okay, so which is a very common mistake. All right, so as previewed earlier, okay, safe we have actually those were the three dangers. Now let's look at safety features. All right, we have altogether double the number of safety features. Okay, the first three work in pretty much the same way by cutting off the circuit, and the next three they have pretty different operations and how they actually are able to manage any problems within the circuit. So let's talk about circuit breakers and fuses first. Okay, this is a very old circuit breaker. Basically, what does a circuit breaker do? The first of six. Okay, they actually switch off the electrical supply when the currents are too large. Okay, because this can actually damage your home appliance. Ah, you see here? Or even start a fire. So why does it start a fire? Because of overloading, right? Just like the video you saw previously. Yeah. Okay. Well, circuit breakers can be reset by switching them on again. Okay, what about the second one? The second one is on a fuse. Okay, after this, I will show you a short video on a fuse. Okay, so a fuse is a safety device used to prevent excessive current flow, must be replaced after it blows. Okay, so what do you mean by a fuse being blown? Okay, basically it means, you see here, I'm sure you've seen one of these. Okay, when I connect, the ends are metal, so it's in between is actually a small thin wire. Okay, when the current exceeds a certain value, every fuse has a different value. Okay, the current heats up the wire, becomes so hot until, remember just like the nichrome wire, the first video we saw in this chapter, it will melt and break the circuit. Okay, so once it melts and breaks, circuit is open, current stop flowing. Okay, so all fuses have a rated value. This value means the maximum current that can pass through them. Okay, they can actually have 3 ampere, 5 ampere fuse, even 1 ampere, 2, 3, 5, 10 ampere, and 30 ampere. These are the typical household fuses. All right. So for safety, okay, the rated value must be slightly higher than the operating current, right? Because if you have something exactly the same every time you turn something on, let's say if 2 amperes is a normal current, and if your fuse is also 2 amperes, every time you turn it on, what will happen? Your fuse will melt, break the circuit. You gotta keep changing, keep changing, keep changing, right? When there's actually no real danger over there, but very inconvenient. So the fuse should always be connected to a live wire. I will explain how using another video, and the main supply must be switched off before replacing the fuse. Okay. So if I use P equals VI formula, everything 12 ampere, the suitable fuse will be 13 ampere. Always remember, slightly bigger. Okay, of course, you don't use something that's 26 ampere, 30 ampere fuse, because those fuses, they are able to withstand such high current. I'm not saying that the fuse you put won't withstand, but because the cables that's connected to your appliance, they may only be operating at 13, 14 amperes. But if you were to bump it up to 30 amperes, even when there's a fault, the fuse still allows that current to go through, right? So not very good. Huh? Okay, another work example over here, if I've got V at 240 volts, power rating of 20 amperes. Okay, since all these four appliances operate at the same time, just add all the powers together. Using power equals VI, this is total current. As a total current is lower than the circuit breaker's rating. What's the rating for circuit breaker? Hmm? Rating 20 amperes, right? So the current is lower, circuit breaker's rating does not trip, can operate safely. Okay, switches more straightforward. They break or complete the circuit and are fitted to the live wire of the appliance. Okay, the fourth one will be on earthing. What is earthing? Okay, if you strip a wire, a typical electric wire, you see actually three different colors. What do the three colors mean? Okay, just like Mr. Brown live show, that's how we remember brown color. Okay, this is the wire to which circuit breakers, fuses, and switches are all fitted. N is a neutral army, neutral wire, also known as neutral army of UN's beret is blue. Okay. Last one, when you lie on Earth, there's always grass, green grass and yellow sun. Remember we talked about this in class? So Earth wire must be green and yellow and connected to metal casing of the cable of the appliance. Okay, so just draw this table down. This will just tell you in normal operating conditions, your live wire will the voltage will always be 230 volts and neutral wire 0 volts. Okay. What about Earth? Earth at any time when it's operating is always 0 volt. Only when it's something wrong. Okay. So the current, what's the current? When it's on, it's high or neutral also high, but the current in the uh, other setup is actually 0, and neutral wire is also 0 in that. Okay. Okay, I'll just stop here, show you a quick short video on earth wire. Okay, I'll be back. Just see you soon. Hope you enjoyed this.